Hey everybody, this is Larry. This is July 6th, the 6th day of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Reduce array size to half. So, okay, let's see. I usually stop this live just as a warning, so if you find it to be a little bit slow, fast forward or whatever you need to do. But my idea is to give you a sense of what a quote unquote a real engineer, how I work on a problem that I haven't seen before, or at least haven't done in a while. Okay, so given an array, you have a set of integers and remove all occurrence of these integers in the array. Return the minimum size. Say what? Do we have to do that in order? This is a very confusing problem, maybe. Minimum size of the set. So, okay. So you're trying to remove as few numbers as possible so that it reduces to half. Okay, so this is just a sorting problem. I think it's a very confusingly read thing because minimize the size of the set. Okay. Yeah, so this is greedy, right? So it's sorting because it's greedy, and it's greedy because at any given point you want to remove as many integers as possible because there's really no benefit of not doing it. Like there's no a sort of decision, right, where you'll be like, okay, if I do A and B versus C and D, then that's. But here when you're given a choice between removing two items, you always choose the one that wants to be that has more items in the list, and you remove them, right? So that's basically the idea here, and then it becomes implementation. And there are a couple of ways you can do it. The way that I'm going to do it is just by keeping track of how often each item gets each item shows up in the array, and then just sort by the frequency and then just walk by one. I think that's going to be my strategy. And key thing to know here is that the output is you don't need to return the array in any way, even though that shouldn't change anything other than just make it more annoying. But because of this, you can kind of you can play around with it in a bit. Yeah, I wonder if this. I'm just thinking about upsolving already. Where like, is there any way to kind of do this without sorting or anything like that? Don't know if you can. I think you need to, but I could be wrong on that one. Maybe we can play around with some lower bounds. And one common way to do, if you have an n log n algorithm and you're trying to figure out if that's the lower bound, one way to do it is to kind of reduce another sorting problem to it, so that, or a comparison based sorting problem to it, or the other way around, reduce it to a sorting based comparison problem, because if you can do that, then that is going to be your n log n lower bound. But I'm not really strong on that part. That's just a theory, so I'm not going to do that here. But okay, let's just get started then. So in Python you can actually do this, and actually it will it initialize this with a frequency table of how many times each element appears in the array, so we can print it out here. This is more of a shorthand for sure. Just want to show people, so like 3 happens 4 times, 5 shows up 3 times, so forth, which is what we expected. But because for learning, this is a little bit almost too convenient, right? That's why I don't know how to approach it, because I don't want people to take shortcuts. These things are pretty straightforward anyway, because you can imagine it's something like this, and this is just a hash table, and for item in array, frequency of item increment by 1 or something like that, right? So that's basically what this code does. So keeping in mind how to do it in other ways, because sometimes you get an interviewer whom if you do this too fast, you just breeze through it. So they're like, oh, well, can you do it without counting or something, right? So I mean, for this particular case, it probably is trivial for you to to do that, but I just want to get people some ideas. So then now that we can think about it a second, we actually, because we don't have to care about what the values are, we actually don't even need the value, the keys of this counter, right? Because if you look at this hash table, it shows up that you know 3 appears 4 times and etc. But we actually don't even care about the 3 or the 5 because we only care about the number in this particular case, even though maybe that's not really extensible. But then here we can just look at the values of the thing, and then now we can sort it by we can sort it, and we want reverse to be true. Basically we want it to be biggest first, right? And then now we have this array, so then we can iterate through it. So for value in this, what does that mean, right? Well, let's look at the size of n first. N is the length of the array, of course, and we want to keep going until n over 2, and n is even, so I don't think we have any, because I remember seeing n being even. Oops. So we don't have to worry anything about off by ones, maybe. I guess you could still be sloppy because I definitely have done it before. So at least half, right? So okay, so now we moved, say you have here just to keep track, and then count 0, 0. So we move is just number of numbers removed, total numbers removed, and here is just number of size of the set removed. So the difference is that here we want to sum up the count. So in here we'll go, okay, we incremented by if and also count increment by 1 because we removed 1 additional number, and then if removed is greater than n over 2, and at least half. Okay, and usually I just do it by 2 to the other side, just makes things slightly easier. Then now we remove we return count, and that's basically it. And we don't, I guess technically, okay, I guess if there's 0 items, then we should return 0. So I think that's the base case. Though I don't think there could be 0 items, because if there, and this is kind of also funny because n is even, so n cannot even be 1 either. So n has to be 2, and if it's 2, then this goes through this array at least once. So this will always be true. So this would actually never be reached. So you can maybe, to convince yourself of that, you can maybe do something like, throw exception here even. But I'm not going to do that just because I don't know what Leetcode servers do, but that's basically the idea, just to kind of think through it a little bit. Because you may ask yourself, what's a reasonable thing to return there? And that's a reasonable thing to ask. But it actually never reaches. So I'm just doing the montage in real time of me copying and pasting and running in the test. It looks good, so let's give it a quick submit. Cool. So what is the complexity here, right? So it's going to be, let's go over line by line for a second, but there are not that many lines. So yeah, so this one's going to be O of n because we went through the sketched out algorithm, but you have to look at each item at least once to kind of build this frequency table. Here, how many values can this have? Well, if every number is unique, then you have n values for an array of size n. So therefore, sorting it is going to be n log n. And here you can easily see that within each element, or for each element, you have O of 1 time, so constant time. So this is going to be dominated by this sort, which is n log n. And given that n is equal to 10 to the 5th, it's going to be fast enough. So yeah, that's all I have for this one. Hope everyone have a happy Tuesday, happy July. Stay good, stay cool. I'll see you later. It's a good mental health. Bye bye.